Okay, the other fundamental thing that you're going to be doing all the time with data is data manipulation, i.e. getting data from what you've loaded into some format that's useful. So I'm going to use a few different data sets here. I'm going to use some psych data that's got some personality items called the BFI. It's just some personality data, and I'll also use this social survey data. One of the things I often do when I'm running analyses is I find that I have to run analyses with particular sets of variables. So for example, this BFI data includes 25 personality items, and it's got some demographics as well. So if I wanted to run analyses just on the items, I might store them in a variable. And so you can get the names of BFI like this, or perhaps this is a trick, dput. We'll put those names into something like that you want to use in our code. And then I'd say, oh, I want to do some analyses on particular variables. So yeah, I take out the ones I don't want. And maybe this is getting into too much technicality, but one of the things I love doing is I create a variable called v, which is a list. And then I create various sets of variables using the dollar notation. So I'll have, I don't know, v.items like that, and then maybe I'll have v demographics as these ones. Oops. Let's get that right. Live demonstrations. And this is a little aside, but I think it's a really helpful way of working with R, is to have, instead of having to retype your variable names every single time, you can store them in little sets. And then, I could say head, BFI, and then extract just those demographic variables. And there they are, or I could describe them using hmisc. And there they are. Or I could go to the items, and maybe I'll use the psych function. Because the psych function only likes numeric data, and maybe I just want to summarize the items. So it's a little bit of an aside, but yeah, that's just a little tip I think is really helpful to create lists of variables that you kind of call in common analyses and put them into a set. Okay, so let's talk about actual data manipulation now. You have the aggregate function, which allows you to get sums and means over particular grouping variables. So say you want to get the mean of a particular variable by gender or by a grouping variable. You're running a report and you want to know the means by some particular organizational unit or whatever. You can use this formula notation. So A1 is an item on the survey, and I want to get the mean of A1 by males and females. This is the data frame that contains all that data, and I'm going to use the mean function. So that's what it gives me. It tells me the gender, it must be coded 1, 2, and that's the mean score for each item. If the first argument of the function is what you're trying to pass, like you're passing A1 to this function mean, then you can just write it mean and it'll understand. So essentially, X is the values of A1 for that particular group. The alternative and more flexible way of using the aggregate function is to have the variables you want to get means for. So in this case, A1, but it could be a set of variables. Then in a list, the variables that are going to be grouping ones, and then pass a particular function like the mean. If you want to get information about averages over rows. So say I wanted to get averages for each person. I wanted to sum up the scores for a person, or I wanted to do some function over rows. You have the apply function. So we have these items. It's a lot of them, but if I wanted to get the mean of each row, so row-wise, I would use the apply, and then 1 tells we're working over rows, and then I would use the mean as the function I'm going to pass. So that apply function is then giving me the mean score for each person. So that's the average response. So for that first person, the average response was 4.16 from a set of responses, 6, 6, 5, 6, and so on. And it can get more complicated. You could define any function you like over rows. So if you wanted to see how many times a person is given a response 1 or 5, you could use this data set, which has all the personality data, over rows, and you're going to get the sum of responses that are in the set 1 or 5. Now this is just illustrative and it's a little bit complicated, but the idea is that you could define an arbitrary function that you want to operate over rows, and you could save that to your data. So this then tells me, well, how many people had all 1s and 6s. There's 25 items, so 1 or 2 people did. And maybe you could filter out, survey respondents who are too extreme or something like that. Okay. 2 other really powerful data manipulation tools are lapply and sapply. Lapply and sapply, they generally operate over lists or vectors, like the elements of vectors, the elements of lists, or the variables in a data frame, which are sort of like elements in a list. So in this case, I'm going to show elements of a data frame. And each element is one question in this data set. There's 25 items. And I'm going to do something, going to do a thing for each item. Specifically, the thing I'm going to do is get the mean for each element in that list, i.e. each variable. So essentially, it's given me the mean score on a, I guess it's 1 to 6 scale for each item. So the first item mean was 2.3, the second was 4.8. And I think if we looked up what the items were, it would probably make sense. So I am indifferent to the feeling of others. So that's not a very friendly or nice item. And it was a 1 to 6 scale, and sure enough, people were pretty low on it. So that's good, right? People care. Okay, the difference between lapply and sapply, not much. Sapply, S stands for simplify. So it attempts to simplify the data that's returned. So if it's possible to convert it to a vector, it will. Whereas lapply returns a list. And sometimes it will return matrices rather than lists. So lapply and sapply, they're just sort of slightly different variants on what's returned, and depending on how you're going to use this, you might want one over the other. Okay. Note that you can also use these over vectors, but most operations are vectorized anyway, so you generally don't have to do that. Just to illustrate how lapply, sapply are really handy, and we haven't got to regression yet, but you can imagine you're fitting a bunch of models that predict something. So I'll create a list of fits, and I'll fit 3 different models. One predicting income from gender, one by gender and size of household, I think it is, one from the unemployment rates and so on. So I've got 3 models. And if I could look at each of those models, and it would tell me the coefficients, and we could get R-squares and all that sort of thing. But I could also extract, generally, I'll explain this later, but there's a summary function for a particular model. that shows the R squared and all these sorts of things. So I could loop that summary function over all the fits, and that would give me the summary information for each thing. And then, once I know that actually I can extract the adjusted R squared or some particular property of interest from each of those elements, I could then loop over those fits and see how I'm substituting. I'm looping over all the S fits objects, which is fit 1, fit 2, fit 3, and I'm extracting a particular thing. So in this case, adjusted R squared. So I've looped over the models, and for each model I've extracted the adjusted R squared. And we can see here that the third model explains 11%, the second 7%, first one not much at all. Now there's a fair bit of advanced stuff in all that, but the main point is that often you will have these lists of elements and you want to extract something particular, and you can loop over those fits or those tables, or maybe you've got different other things, and you can get a particular element that you extract out. Another thing you might want to do with data sets is reorder it. So you've got the order function, which you can use. Basically, you insert it into the row selection of a data frame. So if you've got CBFI as your data frame and you want to order by, say, people who've got some particular characteristics, you can put the order function, decreasing or increasing, into the row selection. The order function will return indices of the cases in the order that will basically perform the ordering that you've requested. So in this case, I've ordered by decreasing values in extreme response. And by default, it sorts or orders in increasing order. Talked a little bit earlier on about extracting subsets of data using logical operators in the row selector space. So maybe you wanted to get rid of the people who had 25 or more, extreme responses. So we've got a logical selector here, whether that extreme response is less than 25. We put that in the row space for selecting cases, and there we go. We've removed so we see that we've got 2231 cases, and now we previously had 2236 cases. So yeah, you can select cases that way, which can be quite nice for cleaning your data. You're going to throw out some cases with too much missing data or extreme responses and so on. You can also, obviously, we've talked about selecting variable names using the column selector area. And a more general kind of, well, not more general, but just perhaps a different approach to selecting is to use the specific subset function, which allows you to specify subsets and select specific variables. So it does the same thing. Just talk briefly about manipulating matrices or data frames from that matter. If we have a matrix like this, we can add columns using cbind, column bind, and that works. And we can also add rows with rbind. So if you're kind of composing maybe a summary table and you've put in your means and SDs as two columns, you can potentially do that and then add further columns using cbind or rbind, depending if you're adding rows or columns. Another thing that you might be doing if you have multiple data sets with a common ID, like if you used a database language, you've got a join on a common ID, you can use the merge function. So I've just created, this is the mean number of kids born per woman or per household or something in that year in the data set. And say I wanted to put that information into the row level data to see whether some sort of general trend of birth year predicted, I don't know, female income or some other individual level variable. I have a common ID. I've got birth year as a common ID. So I'm going to merge on birth year. So as long as the IDs are specified and common, and there's just one of them, I can put in the two data frames and it's added one more column. I usually do it into temp first, and if it looks like it's worked, I'll override the original, which is my intention. So we've sort of added this extra column to our data set, which has the mean number of kids for that year, which could then be used in modeling. Yeah, if you're working with longitudinal data or if you've got multiple data structures with a common ID, then that's quite handy. I might skip over reshaping, but you can go from long to wide format if you're doing longitudinal data analysis. Finally, speaking of the Hadleyverse, which I've brought up a few times today, there is a function, a package called dplyr. There's also something called tidyr. I have given you a reference card for that. That's also available in RStudio. Essentially, this replicates a lot of what you can do in what I've just shown, but in the Hadley-Wickham way. I grew up with base R, which is what I showed today, and I find it, I sort of get along just fine with it. But if you're starting from scratch, it's sort of up to you. You might find the Hadley-Wickham way of doing things more friendly. You can sort of see that they're basically duplicating a lot of the functionality. Sometimes, it's nicer what you get back. So, for example, here we're seeing we're getting particular summary statistics or summarized by each. Oops. And so on. So yeah, I'd encourage you to explore dplyr and tidyr. They're quite nice. I quite like using base R in general, and I've learned how to use all those tools in base R, but I know a lot of people rave about the Hadley-Wickham option in terms of dplyr and tidyr, so that's sort of an alternative. So yeah, we've got a little example on data manipulation here, and then we'll move to actual sort of modeling and what you can do with R. So yeah, we might do that for 10 minutes or so.